Okay, so in section 2.3, we're going to start to look at calculating numerical values that we can use to describe what's happening in a data set. And in this section, we're going to start by looking for the center of the data set. And we're going to talk about 3 different measures of center that we can use. The first of these is definitely the most common, and it's what we call the mean of the data. Now, even if you have not heard that term before, the mean, you're actually already familiar with this value. You may have just heard it referred to using a different name because the mean is the exact same thing as the average of the data values. So, averages we see all the time. And so you're already familiar with this basic calculation. We just add up all of our data values and we divide by the number of values that we have. So since we're all very familiar with this calculation already, I wanted to take a minute here and start to talk with you a little bit about formula notation, because you're going to start to see this more and more as we move forward into some of the remaining sections in Chapter 2. And so the first thing I want you to do is note down here these different symbols and letters that you're going to see used anytime you're looking at something that is written as a formula. So these are just things that you want to make sure that you are familiar with. The first one here is the Greek letter sigma. That's what we always use to denote a sum. So anytime you see that big sigma in a formula, you know you're going to be taking the sum of whatever comes after it. All right, now when you're looking at a formula, anytime you see the variable x, that is referring to your data values. So let's say, for example, you were looking at a formula and you saw sigma and then you saw the variable x. All right, the way that you would read this, it's kind of like telling you what to do. It's a step, is, okay, I'm going to take the sum of all the values in my data set. Okay, so X is kind of a stand-in for all of them, all right? It means you're looking at all the values, the speeds, the heights, the weights, whatever it happens to be in your data set. All right, and then the other values that we're going to need a lot are the number of values that we have, and that's always going to be denoted with N. So we're going to use capital N to denote the number of values in a population, and we're going to use lowercase n to denote the number of values in a sample. These are the terms, some of the terms that you had to learn in Chapter 1. So remember, population is everything, all values of interest. Sample is a subset, a smaller group that you take from your population. Now, we also know from Chapter 1 that the values we take from a population or a sample, those are denoted differently as well, because anything that we take from a population, that's classified as a parameter. Anything that we take or calculate from a sample, that is classified as a statistic. So when we talk about the mean, we're going to be pretty specific as far as whether we're dealing with a population mean or a sample mean. Okay, so let's start with the population. Population means we've looked at all possible values, every value of interest. If we do that and we calculate its mean, its average, we're going to denote that using a Greek letter. All right, and this symbol that you're seeing here, this is the Greek letter mu. Now, if we're only looking at a sample, a subset of the population, and we calculate its mean, we're going to denote that as a value of x bar. And that's just written with x and a little line over the top of it. So you want to be familiar with these things. When you see them in a formula, you want to know mu is a mean for the whole population. X bar is a mean for just a sample data set. All right, and then again, just understanding this formula notation, if we were going to write the mean as a formula, right, using the notation that we just defined, the population mean would say take the sum of the data values and divide by capital N, the number of values in the population. The sample mean, x bar, would say take the sum of the data values and divide by lowercase n, because lowercase n represents the number of values in the sample. Okay, so I just want you to start getting used to seeing things in this format here, formula notation, rather than always seeing everything in this format here where it's written out kind of step by step in words. All right, okay, so we've got our mean, which again is nothing more than taking the average of the data values. The second measure of center that you're going to be using here is called the median. All right, now a couple of important things to note about the median. Number one, if you're looking for a median, you have to be dealing with an ordered data set. So you have to make sure, like what you're seeing here, that you're looking at data values that are arranged in ascending order. If they're not, you need to do that first. The second thing to note is we have kind of two cases. So we're going to talk about what happens when we have an odd number of data values and what happens when we have an even number of data values. All right, now with an odd number of data values, like our first example, you're going to be able to find one number, one data value, that sits all by itself in the center. And what I mean by center, it's got balance on either side. Notice that value has 3 below it and 3 above it. It's in the center, right? There's balance on either side. So in this case, we would simply say the median is that middle data value at 268. Now, if we have an even number of values, this doesn't happen. All right, so take a look at our second example here. If I try to pick just one number that's by itself, I can't have balance. Like if I think it's 235, well, there's 2 values below and 3 values above. So that's not balanced, right? Therefore, it can't be the median. If I think it's 268, all right, then I'm going to say, well, there's 3 values below and 2 values above. Again, that's not balanced, so it's not the median. So with an even number of data values, what we have to do is look at the 2 middle values. If we take the 2 middle values, then we have balance on either side, right? 2 below, 2 above. But now you can only have one median value. So if this happens, what you're going to do is take the 2 middle values and you're going to calculate their mean or their average. So you're just going to add those together and divide by 2 to mark the median at the exact center of the data set. So if I do that here, I'm looking at a median value of 251.5. Okay, so we've got our mean, we've got our median. Those are 2 possibilities. The third option for marking the center or finding the center of a data set is to look for the mode. Now, the mode is no calculation whatsoever. All you do to find the mode is you look for the value that occurs with the greatest frequency. Remember, frequency from section 2.1, how many times does a value occur? So when you're looking for the mode, you don't have to order data, but it can make it easier because you're looking for values that repeat, and this will group them together. Okay, so for example, here in our first one, the only value that repeats is 235. So basically 235 has frequency 2. All the other numbers have frequency 1. And so the value with the greatest frequency would be my mode. Now, a couple of special cases here. You may have data sets that don't have a mode at all. And that's what happens in our second example. Notice nothing repeats here, right? Each value occurs one time. If everything has the same frequency, nothing has a greater frequency, then you say the data set has no mode. And that's not just for value or for data sets where nothing repeats. It would also be true if, say, every value occurred 2 times or every value occurred 3 times. The key is if there's nothing with a higher frequency, then the data set has no mode. All right. And then the flip side, you can have multiple modes. So in our example here, if we look for values that repeat, we have 235 that occurs 2 times, but we also have 274, which occurs 2 times. And everything else occurs once. So these do have the greater frequency, but they tie for the highest. And so in this case, it's not like the median where we take their average. We just state that this data set has 2 modes, and those values would be 235 and 274. So you can have 2 modes, 3 modes, 4 modes, etc., if the values tie for the greatest frequency. All right. Now, a plus to working with the mode, even though it's not one of the more common measures of center, is that this is the only option that can be used when you have qualitative data. All right. And it's another term from chapter 1. Qualitative data is non-numerical. Labels, categories, names. When you're dealing with qualitative data, right, like what we have here, notice this is non-numerical data. These are political parties. All right. I cannot talk about a mean and I cannot talk about a median. If I were asked for it, I would just have to say this data set has no mean and it has no median, because only numerical data can have a mean or a median. All right. Now, don't ever be tempted to want to look at frequencies and find their mean or their median. That does not tell you anything. The only thing that a frequency does is it tells you how many times the particular value or response occurred. So in this case of qualitative data, non-numerical data, all I can do is talk about the mode. Okay, there's no mean, there's no median because they're not numbers. I can, however, talk about the mode by looking for the party that occurred with the greatest frequency. Democrat occurred 46 times. Therefore, Democrat had the greatest frequency, and that would make it the mode of this data set. Okay, so that's kind of a special case that you want to keep in your mind when you're going through the homework. If you come to a data set that is non-numerical, right? Non-numerical things, and all you have are the frequencies, the only thing you can do is look for your mode, right? You have to state there is no mean and there is no median for qualitative data. All right, so let's do one more example together, and then you're going to go into your practice and start working through these on your own. And we're going to go with a quantitative data set, numerical data set. And in the case of a numerical data set like what we have here, we can talk about all 3 measures of center: the mean, the median, and the mode. All right, so I want you to try to work through this on your own. While you do that, I'm going to kind of work through it as well. But try to work through it on your own. And then once I get through writing it up on my end, then you can come and check to make sure that you came up with the same thing. Okay, so quick rundown. The mean, again, all I did was take the sum of all the heights. That's where I got my 1,193. And I divided by 15 because there were 15 heights. And when you state a measure of center, it's always good to include the units because you're trying to describe the data. So notice in this case, I said the mean height is 79.5 inches. Now for my median, the first thing I did was put the data in ascending order. And keep in mind, if you have a large data set, it's always okay to, throw it in your calculator or Excel or even StatCrunch and let it do a quick sort of the data. Put it in ascending order, especially when you're dealing with larger data sets because sometimes it can get a little tedious to do all of that by hand. All right, but make sure that you're looking for an ordered data set. And then I said, okay, this is an odd number of values. I had 15. So there was one value sitting by itself in the center. It had 7 values below and 7 values above. That made it the median of 80 inches. And then there were 2 modes because 80 and 81 both occurred with a frequency of 3, which was the highest frequency. All right, so what I want you to do now is go to your practice for section 2.3 and try several of these problems, looking specifically at problems between 6 and 14, where you're going to be asked to find the mean, the median, and the mode. And then what I want you to do is come back and watch my second video where I'm going to walk you through the steps for finding a weighted mean as well as the mean of a frequency distribution.